just wanted to go a little bit further into depth on indexing in XPath. I know we talked about that a little bit, but we're going to talk about it a little bit more. There are a few examples here. We saw this already, indexing a single element. In this case, we're looking to find the second instance of a table with the class that equals 1, 2, 3. There might be multiple of these, but we know we want the second one. If we're trying to index multiple elements, we know we want the first one. We're looking for a table with a class of 1, 2, 3. Following that third table row, following that the fourth table data. And then you can also do nested indexing. So this is where things get a little bit more confusing, particularly if you were nesting any further than this. But in this case, we're saying find the second instance where there is a fourth table data inside the third table row, inside an instance of a table with the class 1, 2, 3. So it's not going to look for the second instance of a table with the class of 1, 2, 3 and then try to find that element. It's only going to look for the second one where there are also these nested elements. So you have to be a little bit careful if you're trying to do that with the order of your parentheses here. There is an order of operations that's taking place with this indexing. So it's important to keep that in mind while you're doing that. And then something that you sort of may have seen already just implicitly, which is if there is not an index specified for a given element, the index is an implied index of 1. So places that you would want to use indexing is when the only unique attribute of an element is its position. So everything else is either subject to change. If we were looking at this example here, there's some letters here. If these weren't consistent, we didn't know what was going to be in these. The only thing that's around anywhere is this class. So we can't just select on class. We have to also select on position in this case, or the element does not contain any predictable and consistent text. This is a pretty common example where there's a table that has a nice ID, but as soon as you get into the table rows and table data, stuff stops having any good IDs to look at. So you're going to have to rely on position instead. So we're looking at the second table row here and then the third table data inside of that, because that's the only good way to get to that element. This is some examples of when not to use XPath indexing. And this is sort of what we saw, what Zach was showing, where it was looking at like the 29th index of a list item. And the reason we don't want to do that is basically what he mentioned. If something were to change anywhere on the page beforehand, that index is no longer what we want. So if we're seeing an example like this, where there's this div here that has an ID, but it's not really until 17 divs down again that the element we want appears, that leaves a lot of opportunity for something to go wrong there. As an alternative solution to this, because right now this is really the only way to do it, right? But we can use some of the string functions that we looked at earlier to select that element. So in that case, we would probably want to use either the starts with or the contains function. If we assume that this XYZ is consistent in that element, we could use a starts with XYZ, text XYZ to be able to select that particular element. Just to go over some of the string functions that exist, we can use contains with any of the attributes that exist for an element. So in this case, we're looking at text and we want to find the list item that contains the text C. So we're selecting this third one here. In this case, we'd be looking for a list item with an ID that starts with ABC. So we're just finding this one where the element starts with ABC, even though this one also contains it. This one starts with it, so we're getting that one. Same thing with ends with. We can check the other side. In this case, we're looking at a class with ABC. So this one ends with ABC, so we're grabbing that element. Another way that we can aid ourselves in selecting particular elements that don't have their own unique attributes is using XPath axes. So an XPath axis is roughly equivalent to the concept of anchoring in the web script builder, Internet Explorer, syntax of EMU, if you're familiar with that. If you're not, I'm going to go into detail anyway, that's fine. But it's used to select elements that don't have a unique attribute of their own, but kind of are surrounded by ones that do have more unique attributes. So you can grab onto something close by to the element you want and then direct XPath from there to the element that you do want. This is the example of the syntax here where you'd have the initial anchor point, something that does have a good and unique attribute that you can grab onto. Then it'd be slash, put in the axis, 2 colons, and then the target element. And that can be done as many times as you need in any given XPath statement. So one example of one of these axes is the siblings axis. If we look at this first one here, where we're not using an axis at all, we're just looking at the li with an ID of 2. So we're grabbing this middle one here. But then if we use the axis preceding sibling, so we're looking at the sibling that is before this first element, we're grabbing the one that's directly before it. So we're looking for another li with an index of 1. So just going 1 back. And then the opposite same is true with following sibling. So these are on the same level within the same element. So it's just looking at a sibling element next to it. There is preceding and following. This is sort of similar to sibling in a sense. We're looking at following, preceding, but these do not have to belong to the same parent. They don't need to belong even in the same family tree in essence. It's just going to find, starting at, in this case, the paragraph with an ID of ABC, it's going to find the following span anywhere in the document starting at this paragraph tag here. It's going to find the first instance of a span after that. And same goes for preceding, just in the other direction. Parent and child is another one where it's just going to look at the direct parent. In this case, if we have the table row with an ID of ABC and we're looking at the parent table, it's just going to go up one layer to find the table. Again, same goes in the other direction for child. If we were looking at the table and wanted to find the first child table row, it's just going to grab the first one there. Ancestor and descendant, similar to parent and child, but it can be any number of generations in either direction. So it's not going to just look one up or one down like parent and child. You can go in however far you'd like. I also want to talk about wildcards and Boolean logic in XPath. This is where things start to get a little bit more interesting. Wildcards get used a lot when we're looking for elements because we don't always know what's going to be in them. We don't always know what they're going to be. Sites are weird. People who are designing them make choices where things are dynamic. We can't always make a decision saying this is going to be consistent forever and always. In this case, we have wildcard elements in XPath. Instead of having a tag name here, we can put an asterisk there, and that says find the first element in general, any element that contains text ABC. If for whatever reason the website had a chance of returning any one of these tags in the place that you want it to be, you can just use an asterisk and it will grab any one of those. You don't have to have 3 different statements looking for 3 different elements. You could just specify it with the asterisk here. You can do that anywhere in your XPath statement. So if for whatever reason there was something in the middle of your relative path that was liable to change, you could just throw an asterisk in there to replace that. And it should be noted that care does need to be taken when you're using these. It does make it less specific. You do run the risk of grabbing elements that you don't want if you're not careful with using these. So I wouldn't just use them anywhere. Make sure you know what you're doing when you use them. And the other place that wildcards are used all the time, particularly in the old syntax, is when you're looking at inner text for things. So you want to say, I know that this particular element is going to say patient control number, member ID, or something in there. Unfortunately, XPath does not really support that. And I do have a way of doing that, but we need to get a little bit off track first. So I'm going to talk about Boolean logic really quick. This is something that many of you are probably a little bit familiar with, but just in case you're not, I'll go over it really quick. The 3 main ones here that we'd be using in XPath are and, or, and not. If we had multiple conditions in an XPath statement and you wanted them both to be true, you'd use an and. If only one of them needed to be true, you'd use an or. And if you wanted one of them to explicitly not be true, you could use a not. And there's just some truth tables here that kind of show you basically what I said. It's not crazy. We'll move on to some examples of when you might want to use that. These help when particular elements are only unique when you consider a composite of their attributes. In this case, we have 3 divs here. 2 of them have the class of ABC and 2 of them have inner text of B. So you can't choose just one because then you're going to be grabbing 2 elements with either one of those things. But if we take a composite saying, okay, well, I want the one that has the class of ABC and has the text of B, then we're being specific enough to just grab the one element. Similar to before with the wildcard elements, if for whatever reason a website, and I have seen this actually, has one element and it's consistent in a lot of ways, but for some reason there are 2 possible IDs for it to have, you could say, okay, well, I know it's going to be a div in whatever position, but it might have this ID or it might have this ID. This way it can grab either one depending on whatever situation you're in. You don't have to write 2 different statements or 2 if statements to check which one is actually there. It can just be included in the XPath. This bottom example, not something you're probably going to use super frequently, but is useful to know about anyway. And that's including the not here, where again, we have a bunch of things that are really similar here. And let's say the X isn't consistent. So you can't just say where text equals X, that could be anything, but all the A's are consistent. So you could say, well, I want the one that has a class of ABC, but does not have the text of A. And therefore you'd always be grabbing the one that does not contain the A. Moving on to the problem that I brought up earlier, which is you want to be able to use wildcards. Here's another scenario that we see sometimes where the ID ID is consistent in some places, but is liable to change in others. Say these numbers or letters could be anything. If we were following how Emu had things before, it would make sense that you could just say, okay, we'll just put an asterisk in there and it'll be fine. Unfortunately, XPath does not actually support that. So the solution there is to use some of those Boolean logics and functions that we were just talking about. Instead of this, we say, okay, the ID starts with start and it ends with the ID of end. And then there's sort of an implicit wildcard in the middle here, because all it's checking is for this at the start and this at the end. XPath doesn't actually care what's in the middle. That's all it's looking at. And now we're going to talk about iframes a little bit. An iframe is basically another HTML document within an existing HTML document. In this example here, this would be the parent or root HTML document. There'd be an iframe tag here as such, and then inside would be an entirely separate HTML document. The unique thing about these, and the reason that we're talking about them at all, is particularly if you're using the inspector dev tools in Chrome or whatever, and you're using Control F and you're looking at XPath elements in there and you're finding them the way that you would expect to. So in this case, we're just looking for a span with an ID of 1, 2, 3. It's going to find it just fine in Chrome, but if you're writing the statement in Emu by hand, it won't work. And if you're not paying attention or didn't notice the iframe, that's wise, because you're inside of an iframe and you're not telling Emu that you're inside of an iframe. I would say 9 times out of 10, if you have XPath that works in the dev tools in Chrome but doesn't work in Emu, it's probably an issue with an iframe. This is how we are going to handle them in Emu. This is the syntax that would be in Emu for the selector string. We have the web page name, we have the XPath here. I don't know if you've ever noticed those 2 colons hanging out between those. That is the space to put the iframe name in. So if the iframe has an ID, you're going to say, okay, we're inside of this iframe. So we're saying ID of 1, 2, 3, and then we can go ahead and select an element that's inside of it. If there's iframes within iframes, which is terrible, but it does happen, you're going to need the ID of both of them, and you put this nice little arrow in there, which is just a dash and a greater than sign, and that is going to say that this is the parent iframe, and then the one that we're actually looking at has an ID of ABC. Another situation that I sure hope you don't run into, but it does happen, where there's an iframe that really doesn't contain any ID or name. There is a way to handle that, and it is this specific string here, frame underscore wait in. That is Emu's way of looking for an iframe that does not have a name. You could combine that with this nested syntax if that were to come up. Something else that can happen but is rare, I've only ever seen it once. There are multiple unnamed iframes that are siblings, basically. You can specify, but you wouldn't necessarily intuitively know how to specify which one Emu's looking at. If there are sibling unnamed iframes, they can be indexed by just throwing the number at the end of the iframe that you are looking for. You sure can. That would be the same embedded variables that you'd use in any other string in Emu. So the curly braces and then the name of the variable on the inside, you can put that in XPath and it will work. If the element that I'm looking for doesn't have a unique attribute, that would be the first step, is look at the element that you want. And if it has a unique attribute, great, use that, go with that. If it doesn't, look for the closest element that does have something unique. Use a combination of either those string functions talked about or the axes to anchor off something that is going to be consistent and then navigate to the element that I actually want. Using those dev tools is incredibly helpful because you can do trial and error. It'll tell you if you found the element you want or not. The implicit escape character would be the quotation marks here. So the only time that you'd ever actually be looking for specific text, it's going to be wrapped in these single quotes. So you can put whatever characters you want in there, and XPath will be able to do that. And actually, that's something that's important to note too. If you're ever converting a script that was written with IE syntax or web script builder syntax into XPath, it might be tempting to grab whatever is in the ID and just throw it into an XPath thing. But you want to be careful because Emu does actually have escape characters. So I think it's the colon character gets followed by a pipe character. So if you're converting that over, you want to actually make sure you take escape characters out. because XPath will look for that character and it will not find it. There luckily is no escape character in XPath because it doesn't need them.
Adding on to that, say you have an element that doesn't have any really good attributes or any simple attributes, and you have to go off of the JavaScript that element calls whenever it's clicked. That JavaScript will actually be wrapped within double quotes, and those double quotes will throw off the emu string because the emu string is wrapped in double quotes. So to counteract that, what I do is I actually write double quote out and wrap it in curly braces, because that is the emu syntax for a double quote, and you just plug that in the case of where there's double quotes in the XPath string.
Yeah, something else that I just ran into the other day that's only tangentially XPath related, but if you start looking at HTML more, there's actually an element that you want to grab. You want it in your emu script, but you'll see one of the attributes that's on a number of elements is style. If you ever see style equals display none, that means it's not actually on the web page right now. And using get web value, emu will not grab that in the Selenium thing on the back end, seeing what we see. So if it's hidden in the HTML with a display of none, you won't be able to grab it. But XPath will still see that element. And there is another way, which is if you use get web attribute and do inner text as the attribute, then using that XPath string, you can grab the content of that particular element, even though it has a display of none. So you might actually find more information going through the HTML than you would just looking at the web page without the HTML visible to you.